So let's suppose that a spaceship orbits the Earth once every 2 hours under uniform circular motion. So uniform circular motion simply means two things. It means A, that our magnitude of velocity remains constant, and B, the net force acting on the object on our spaceship acts at a 90-degree angle with respect to the velocity, with respect to the motion of the object. So what exactly are we asked to find in this problem? Well, given the fact that the radius is 7,000 kilometers and the mass of the spaceship is 10,000 kilograms, we want to find what the centripetal acceleration is as well as the centripetal force. So first we must find what the centripetal acceleration is, and then we can use Newton's second law of motion to find what the net force on our object is. So what exactly are we given in our problem? So we are told that it takes our space shuttle 2 hours to orbit, to make one orbit. So that means we know the frequency of our object. So using the frequency, we can find the velocity, and using the velocity, we can find our acceleration. So recall that acceleration is equal to v squared divided by r. And v is related to frequency by the following equation. So velocity is equal to the circumference of our circle multiplied by the frequency. So 2 pi r multiplied by f, where 2 pi r is our circumference. And we have to square this because our velocity is in fact squared. So we square every term, we get 4 because 2 times 2 is 4. Pi squared, r squared, f squared. Where r squared divided by r simply becomes r. So this is the equation that we want to use to find our acceleration. So we know what the 4 is, we know what the pi is, we know what r is, we don't know what f is. And f is the frequency is given by revolutions or orbits per some given time. So we are told that our spaceship takes 2 hours to make a single orbit. So we have one revolution every 2 hours. So we want to convert it to seconds. So we have 1 over 2 multiplied by 1 over 60 multiplied by 1 over 60. So we see that the hours cancel, the minutes cancel, and we are left with seconds at the bottom. So we have 1 over 7,200 seconds, where the seconds appears at the bottom. So now we essentially plug this into the calculator. So we have 4 pi squared times r, where r is 7 million meters, because we want to use meters and not kilometers. So we have 4 pi squared multiplied by 7,000 meters divided by this number squared. So the reason that this goes at the bottom is because when we multiply by this number, this ends up being at the bottom. So we square that, we plug it into our calculator, and we find that our radial or centripetal acceleration is 5.33 meters per second squared. So to find the force, the net force acting on our object, we simply use our equation m times a. So 10,000 kilograms multiplied by 5.33 meters per second squared, and we find a force of 53,300 newtons. And the force points in a direction that is perpendicular to the motion of our object, of our spaceship.